Welcome to all the students. I am Rajiv Kumar Soni and I'll be taking your sixth lecture on simple lifting machines. Now the next topic which has to be covered is pulleys. Now to start with, I'll be starting by taking the working or the concept of a pulley. Now let us consider a single pulley. I think first of all you must have heard the word pulley. Pulley is basically a device you must have seen in your life. Like suppose if you want to fetch a bucket of water from the well, then there also a pulley is being used. Basically the pulley is a circular in shape. It is a body circular in shape and its periphery is made rough, and a rope wound around the pulley, and on one side of the rope there is the weight which has to be lifted, and on the other side of the rope a effort P. Suppose an effort P is applied. Whenever the effort P is applied, the weight is being lifted up. Okay, in this way the pulley works. A pulley is circular in shape. It may be made up of wood or metal, and its periphery is made rough so that to increase the friction between rope and the pulley, it has a central hole so that it can be placed on a shaft. So this is the arrangement. For using a pulley. Basically, on one side weight and one side effort is being applied. Now coming to a single pulley. In case of a single pulley, suppose we are lifting a weight. Suppose this weight is 100 Newton. Then to lift this weight we have to apply a force of 100 Newton. Same force is being applied. Okay, that means the weight and the force, the amount of weight and the amount of force which is applied to lift the weight is same. The reason is that because in case of a single pulley we don't have any velocity ratio. That means if suppose this is the point where the effort is applied. Suppose we pull this point and pulls it for about take it 10 centimeter, then the weight will be lifted up, but the weight which is being lifted up will also be lifted for 10 centimeters. That means when it comes down 10 centimeter, weight will be lifted up by the same amount, 10 centimeter. Okay, if you don't that means there is no velocity ratio, because the velocity ratio is equal to y upon x, that is the weight, that is the distance moved by the effort and the distance moved by the load. If this is 10, in this case this is also 10, so the answers comes to be out 1. So that means the velocity ratio is 1. That means we have got no velocity ratio, and whenever we don't have any velocity ratio we don't have any mechanical advantage. So mechanical advantage is equal to velocity ratio is equal to 1. But this is in case of a single pulley. Then what is the benefit of using the pulley? The only benefit of using the pulley is that we can change the direction of the applied force according to our comfort. That is only the benefit which we get from a single pulley. Now there are many arrangements in case of pulleys such that we can get velocity ratio. So whenever we'll getting the velocity ratio, definitely we will be getting mechanical advantage. But for that there are some arrangements which are being made, and instead of one pulley we are making use of many pulleys. Now according to your syllabus there are 3 types of arrangements which are made by using pulleys such that we get the mechanical advantage and velocity ratio. Now this is the first arrangement in which we are taking some of the pulleys and creating a system such that we get the mechanical advantage and the velocity ratio. And this is the first type of arrangement, and this type of arrangement is known as the first order pulley block. Okay, so in this we are having 4 pulleys. Okay, 1, 2, 3 and 4, but actually there are only 3 pulleys, first, second and third. These are only the 3 pulleys with the help of which we are getting the velocity ratio and mechanical advantage. This 4th pulley is just an ideal pulley which is just being used to change the direction of force applied. So in this case, now suppose there is a weight of, suppose you can say 100 Newton, and this weight is hanged on 2 strings. Then each string will bear 50 Newton and 50 Newton. Okay, the total is 100 Newton, 2 strings. It is hanged with the help of 2 strings, so both the strings will be having 50 Newton and 50 Newton. Okay, this is the basic fundamental you should know. Now first of all, coming to this figure, if suppose now let this be weight. So this weight will be bared by these 2 strings. Okay, let the tension in these 2 strings is T1 and T1, because the tension in both the strings will be same. Like in this 100 Newton, 50 in one and 50 in one. Let the tension in this and this is T1 and T1. Similarly, let the tension in these 2 strings be T2 and T2, and let the tension in these 2 strings is T3 and T3, like that. So the tension in this string will also be T3, because this is only an ideal pulley just to change the direction of the applied force. Now if suppose now coming to the construction, I will tell you something about the construction. Like suppose in this there are 3 pulleys, first, second and third, and we are having 3 strings, 1 string, second and third strings, or you can say ropes. So one end of the first rope is tied here, and it is then passed upon the first pulley, and then it is tied to the center of the second pulley. Similarly, the second rope, the one end is tied here, and then it passes through the second pulley, then the second end is tied to the center of the third pulley. Similarly, one end of the third rope tied here, it passes through the third pulley, and then it passes over the ideal pulley, and then the force or the effort is applied here. Effort is applied here and the weight is tied on the first pulley. So whenever we exert the effort or we pull this point downwards, the weight will be lifted upwards. Okay, so this is the basic arrangement by taking many pulleys, so that we can get the mechanical advantage and velocity ratio. Now here see, first of all, W is equal to 2T1. That means W is bared by 2 ropes, so each rope will be having tension. Now suppose if this is 100 Newton, then 50 Newton here and 50 Newton here, like this. So W will be equal to 2T2. Now this tension T1 will be bared by 2 strings, and both will be having tension T2 and T2. That means T1 is equal to 2T2. Okay. Similarly, T2 will be bared by these 2 strings. So T2 will be equal to 2T3. So T2 will be equal to 2T3, and T3, and both the side the tension will be T3, because this is just an ideal pulley. So effort P is applied such that effort P will be equal to T3, is equal to T3. So these are the tensions of the different parts of the strings. Now coming here, like W is equal to 2T1. Then instead of T1 we can write 2T2. That means which is equal to 2 into, instead of T1, 2T2. 2T2. Then instead of T2 we can write T3 with the relation that T2 is equal to 2T3. So 2 into 2 into, instead of T2 it will be 2T3. So this will be W. But as I have told you that T3 is equal to P, so we can write W is equal to 2 into 2 into 2 P. So W upon P is equal to 2 into 2 into 2. So in general we can write it is equal to 2 raised to power n, where n is the number of pulleys. Okay, like this. We have got 3 pulleys. So 2 raised to power 3, that means 2 into 2 into 2, which comes to be 8. So let us consider this arrangement is a frictionless arrangement. But any arrangement which is having no friction, in that mechanical advantage will be equal to velocity ratio, but both of them is equal to 2 raised to power n. So this is the general formula for the first arrangement of the pulleys, or you can say first order pulley block. So in this arrangement we will get the mechanical advantage, we will also get velocity ratio, and that will be equal to 2 raised to power n. Now to explain it further, suppose we pulls it by 16 centimeter. Okay, this is 16 centimeter. We pull this point by 16 centimeter. Then this point will be raised by 8 centimeter. Okay, because 8 centimeter this will reduce, 8 centimeter this will reduce. So the weight will be lifted by 8 centimeter. If this weight is raised by 8 centimeter, then this weight will be raised by 4 centimeters, because 4 this will reduce by 4 and this side will reduce by 4. So this will be lifted by 4 centimeter and this will be lifted by 2 centimeters. That means if we pull this point by 16 centimeter, the weight will be raised only by 2 centimeter. That means we are getting the velocity ratio, and whenever we are getting the velocity ratio, we will be getting the mechanical advantage. So this is the first arrangement, or you can say first order pulley block, in which the mechanical advantage and velocity ratio comes to be 2 raised to power n, where n is the number of pulleys. We can also increase the number of pulleys, like if we increase this, and if we provide one pulley more and one string more, and if we hang our weight here, then there will be 4 pulleys. So whenever we increase the number of pulleys, we will be increasing, we will getting more and more velocity ratio, and in the same time we will be getting more and more of mechanical advantage. So number of these pulleys are not fixed, they can be increased or they can be decreased or increased depending upon the amount of velocity ratio and mechanical advantage we want to get. So this is the first arrangement. Now coming to the second order pulley block. This is the second type of arrangement. In this arrangement we have got 2 blocks. One is the upper block, this is the upper block, and this is the lower block. That means 2 blocks. 3 pulleys are attached to the upper block and 3 pulleys are attached to the lower block. All the distances of all the 3 pulleys in the upper block are fixed, and the distance between the pulleys of the lower block are fixed, but the distance between the 2 blocks can be varied like this. So this acts as one body and this acts as another body. Okay, 3 pulleys here and 3 pulleys here, so total of 6 pulleys. But in this we are having only one string. See, only one string. The string, or you can say the rope. The rope starts from, first one end of the rope is tied here, then it goes over this pulley, then this pulley, then this pulley, then this, like this, like this, and here the effort P is applied. So 2 blocks, upper block, lower block, both the blocks are having 3 pulleys, and the weight is tied here to the lower block, and the effort is applied here at the end of the string. Now suppose if there is 60 Newton here and the 60 Newton of weight is hanged with the help of 6 strings, then each string will be bearing 10 Newton. Okay, so 10 Newton, 10, 10, 10, all the strings will be bearing 10 Newton because total is the 60 Newton and there are 6 strings. So similarly in this, W is equal to 6T, where T is the tension in all the 6 strings. This one, this one, this one, this one, this one. Actually they are 6 strings which are bearing the weight W. So each string will be having a tension 1/6 of this weight, or in other words, W will be equal to 60. But here in this the tension will also be T, because this is only the tension and this pulley is also working as an idle pulley, or just to change the force, the direction of the force being applied. So this one, so T here will be equal to P. Second thing is the tension will be equal to P. This tension will be equal to P. So W is equal to 60 and W will also be equal to 6P. W upon P will be equal to 6, or in general N, where N is the number of pulleys. Here it is 6 pulleys, it can be 8 pulleys, it can be 10 pulleys. So as we increase the number of pulleys, we increase the velocity ratio and we will increase the mechanical advantage also according to our requirement. So let us consider this arrangement as a frictionless arrangement. So in a frictionless arrangement, the mechanical advantage and the velocity ratio are equal. So W upon P comes to be the mechanical advantage, which is equal to 6. So as it is a frictionless arrangement, so mechanical advantage will be equal to velocity ratio will be equal to 6, or generally it is taken as N, where N is the number of pulleys which are present in the system. So for the second order pulley block, we get mechanical advantage is equal to velocity ratio is equal to N. In your syllabus you are having 3 sets of, you can say, or 3 arrangements of the pulleys to get the velocity ratio and mechanical advantage. 2 are this one, the first order and the second order, and the third order pulley block I will take in my next lecture. That will be the last type of arrangement in case of pulleys. So thank you so much.